Okay, folks. Here's a question from Chapter 2 that talks about the Lincolnville School District bus data. The first thing we need to do here in order to answer these questions is build a frequency distribution, and I have it built here. Let me talk about how we did this. The first thing that we need to do is we need to identify how many cases we have here, and there are 80 data points or cases here. You can go down through the list and see that there are 80. And then the next thing for the classes, the class width, it's this rule of 2. So 2 to what power gives us a value that bounds or is less than 80. And then 2 to the next successive power, which is greater than 80, will tell you how many classes you have. So 2 to the 6th power, and by the way, this is explained nicely in the book. So if you missed this, you can go back and take a look in the book. But 2 to the 6th power is 64, 2 to the 7th power is 128. And since 80 fits in between 64 and 128, we always round up to the next. We don't, obviously nothing in the middle, but we'll take the higher of the two exponents. So we're going to have 7 classes. To help me build this frequency table, notice what I did is I took the H column and I copied it over to the I column, and then I sorted it from low to high. So actually, let me just do that for you and show you how that works. So if I go down here, I get all the data, I right click and copy, and then I hit paste. I have all the data. But what I wanted is I want all the data now from low to high. So what I'm going to do here is I'm going to sort this data. So once you have highlighted all the data, if you go up to data and you go to in the middle here, you have A to Z, which will give you a sorting of all this data from low to high. Yes, I want to continue with the sort. And that will help us here as we build this frequency table. First question here, actually 2 questions here. The first one that's easy to answer, what is the range? Notice that the maximum value is 11,973 and the minimum value is 10,000. So the interval, which I'm starting to compute here, has a range of 1,973 miles. Then to find the class width, I take that range, 1973, divide it by the number of classes. So that comes up to about 282. So I'm going to round that up to 285. And that, if you rounded it up to 290 or 300, that's absolutely fine for this week. What we want to do is we just want to talk through kind of the mechanics of what we're doing here. So under the assumption that I'm going to use a class width of 285, to come up with these classes, here's kind of the calculus that I go through over here. What I did in this first cell is I took 10,000 and I subtracted off 10 miles. And what I want to do, let me explain what I want to do, the ultimate goal here. So if I take 10,000 and I subtract 10 in this cell, and then I take 990 and I add 285 to it, this would give me the first class width, or upper and lower bound of the first class. And that's 990. Am I missing a 9 over here? Sorry, I don't know why I'm missing a 9 in there. Let me tuck that in there. So 9,990 miles to 10,275 miles is the first class. And then what I did in each successive cell, and I'll post this file so you can play around with it a little bit if you want. What I've done is I took each value and added 285 to that. Let me just show you too, also an easy way to do this is once I do it once, if I take T17 and add 285 to it, and if I go down here in this bottom right and just pull this down so that I have 7 classes, 1, 2, 3, 4, 5, 6, 7. What it'll do is it takes the cell above it and it adds 285. So that'll save you some typing, and just kind of one of the tricks of the trade when you're playing around with Excel. The key thing that I want to make sure I do on my last class is I want to make sure that 11,985 is greater than the maximum value in the data, so that this last interval gets all of my data, and it does, so I'm all set. And so what I've done is I've built the classes based on this string of data over here. The reason I have put these both values in the same cell is because when we build the visuals, it'll be helpful to see both values here, I think. So I hope this is helpful to you. Just one point here, if you open up the cell and play around with it, notice that I've got an apostrophe as the first character in each one of these cells. And the reason is because I've got this dash in here in between 9990 and 10275. If I didn't have the apostrophe, Excel would think I'm trying to do some sort of calculation. So what that apostrophe tells it up front is to say, leave the negative alone and just give me the text that I have typed after the apostrophe. So those are the classes. And then the way that, let me just show you for the frequency count for this first class. What I typically do on something like this, there's a bunch of Excel syntax you could do here to do this, but I think an easy way for this week is just, you go over here and click in the far left-hand column, actually to the left of A, and you pull your cursor down until you have found a value that is more than 10,275, which is 10,315, and then just go back up one. And over here, over where my cursor is, the first, I don't know if you can see this, but it says it's 12R. So there are 12 rows here that I have, which means I have a frequency of 12. And then you can go down and you can fill out this table or just count them however you want to come up with the frequency distribution for the data. And I always total this data up to make sure that I've considered I've gotten all the data. And so there are 80 data points. So the only question left here in part A is, what is the typical amount of miles traveled? And that is found, and it's explained in the book. If you find the class with the highest frequency, that class is 11,700 to 11,985, and take the midpoint. So about 11,700 in my case, plus what's half of 285, that's about 142. So about, 11,842 would be the typical amount of miles driven based on the way I have built my frequency distribution. Now, like I said, yours will vary. What we definitely should agree upon is that there should be 7 classes. How you split them up, there might be a little bit more slack here, but it can't be much more, because remember your max value here is 11,973. So that should be, everybody should be close on that. Next thing is kind of the fun part. Scroll in all the data, or just highlight all the data except for the total. Go up to insert. There's any number of charts here, types that you can incorporate. These bar charts are what we're looking for. We can go fancy with a 3D. And let's just pull this up here so we can see the data. Obviously, it all matches here to what we got in the frequency distribution. So question B wants, what's the shape? Well, I think the only distinguishing factor of this that I would say is it's unimodal, meaning that there's one class with a frequency that is clearly higher than all the others. If these two bars were maybe a little bit shorter, I might be inclined to say that this is skewed to the left. But I think for today, for chapter 2, what we'll say is that it's unimodal. So we'll get rid of that so we can build our cumulative frequency distribution. The key thing here is, how do I come up with the relative frequencies? And again, relative frequency is the total number divided by 80. The question is, what's the total in each one of these classes? And because it's cumulative, notice what I've done here. If you play around with the sheet, the first one is whatever's in cell M18. So it's the frequency for this class divided by 80. So that says that there's 15% here. But since this is cumulative, what I'm going to want for 10,275 to 560 is the total number that's in these two cells. So you'll note I've taken the sum of those two cells and I have divided it by 80, and that's given me 22.5%. And you'll see that that's the way this kind of goes, or that's the trend in order to get the cumulative frequencies. Obviously, when we get down here to 1, since we have all the data, we will expect to see a 1 here. And let's see, so let's highlight this, and this one may not be quite as apparent. So let me just go data. Since I'm not, insert. Since I'm not quite sure what chart I will get with one of these, let me just click on the recommended charts. And if you go to all charts, what I'm looking for is some type of line chart, I think. And I think that's what I want. The thing about it is, what I would really like to see is what I really want is a little more definition. And because, as I look at these classes, the relative frequencies, the increases are not drastically different until we get to the very last class. So the only really place where I'm seeing a distinguishing factor is here as I go to the last class. So a way to fix that is, if I go over here and I click on this vertical column and I right click, I can format the axis let's see, I only need a maximum value of 1.0, but I want a little more definition in these major units. And notice they're going by 2/10 in each case. So what I'll do is I will go down to, let's say I'm going to go down to, I don't know, let's go down to 2.5% per click. Whoops, I don't think I got that right. Let's see, sorry, I did it in the wrong spot. And that's why. So let's go down to 0.025 here. And then we have a really more significant level of fidelity in this relative frequency chart. So let me blow this up just a bit. And if I click on the chart itself, here are the points that we would want to match to our relative frequency distribution. So this first class is about 15% of the data. That's right. The first two, about 22.5. And you can see as you put your cursor on here that you have actually built what it is you're looking for. The other question here is, let's see, draw a cumulative frequency distribution. 40% of the buses were driven how far? So the way I have built this out, this is really pretty simple. If I follow this line for 0.4 over, you can see it's somewhere in between 10,845 and 1130, based on the fact that this is the count for 10,560 to 10,845, and then this next count. But if you follow this line over, this 0.4 line, which would represent 40%, it's going to be somewhere within that value. Another way to do that is, let's see, 40% of 80, 40.4 times 8 is 32. So if I just go down to this 30-second value in the data set, let's see, 20, I can't see that myself over here because I'm blocked by something. Let's see, 29, 30, 31, 32. I'm thinking that's about 32 right there. So it's about 10,945 miles. So if you just go down to your 30-second data point, that would confirm what you saw in the chart. Final piece here, what we're looking for is we want pie charts for a couple of the qualitative variables. Actually, this is actually a quantitative variable, and that's fine. So I've already done this. Here's the way I have done the counts. This is a little neat trick that you'll find in Excel. So I know that the manufacturers are Bluebird, Kaiser, and Thompson. Over here I have, and you can see what I have for the syntax. There's this function called COUNTIF. And so COUNTIF, if I scroll in all of the data, the entire string of manufacturer types, and then I have a comma and I put Bluebird in parentheses because it is non-numeric, and hit enter, it will count the number of Bluebird entries, Kaiser and Thompson, and that, let's see, 25 plus 70, let's see, 25 plus 8 is 33, and 33 plus 47 is 80. Same idea over here, but since this is numeric data, you will not put, I actually put the cell value in here instead of the actual value itself, but notice it does not have to be in parentheses, so then you can just get those frequencies as well. And I'll just show you one of these really quickly. If you go to manufacturer, insert, and then just a quick 3D pie chart, that will give you the 3D, and then you can add data labels to your heart's content. More options we would certainly want. Let's see if I can get that here. I was having a little trouble with that just a minute ago as well. More options, yeah, there we go. And then you might want to show the percentages as well. So 47 Bluebirds, which is 59%, and so on and so forth. So I hope this is helpful, and please reach out if you have more questions on the week 1, chapter 2 problem. And I will post this file so that you can play around with it. Take care, and I will see you in chapter 2.